हेलो स्टूडेंट्स, देखो लास्ट क्लास में हम लोगों ने ऑर्थोगोनैलिटी पढ़ा था। आज हम लोग देखेंगे कि कैसे इंडिपेंडेंट वेक्टर्स को हम लोग ऑर्थोनॉर्मल वेक्टर्स बनाते हैं। कैसे, अगर आपको एक सेट ऑफ इंडिपेंडेंट वेक्टर्स दिया हुआ है, सो हाउ वी कन्वर्ट देम इनटू सेट ऑफ ऑर्थोनॉर्मल वेक्टर्स। ऑर्थोनॉर्मल का मतलब है कि वो ऑर्थोगोनल होगा और नॉर्मलाइज हो जाएगा। If we are given set of independent vectors like psi1, psi2, psi3, psi n like this, तो कैसे हम लोग पहले उसको ऑर्थोगोनल बनाएंगे और ऑर्थोगोनल बनाने के बाद ऑर्थोनॉर्मल बनाएंगे। ऑर्थोगोनल से ऑर्थोनॉर्मल तो बहुत इजी है ना। ऑर्थोगोनल से ऑर्थोनॉर्मल तो बस उसको नॉर्मलाइज कर देंगे। तो मेन काम तो है कि कैसे हम लोग इंडिपेंडेंट वेक्टर्स को हम लोग ऑर्थोगोनल वेक्टर्स बनाते हैं। लेट मी शो यू व्हाट वी आर ट्राइंग टू डू। Suppose we are given independent vectors. Suppose we are given set of independent vectors. Say set of independent vectors. पहले दो का ले लें. Let's take set of two independent vectors. Set of two independent vectors. Say psi1 and psi2. If we are given set of two independent vectors का मतलब they are lying in different direction. They are lying in different direction. One is not the multiple of other. If they lie in same direction, अगर मान लो यहाँ पे पेन है क्या? चलो पेन तो नहीं है, ये पेन का कवर है। इस मान लो ये एक वेक्टर है और ये एक वेक्टर है, ठीक है। सो इफ दे लाई इन सेम डायरेक्शन, आई वोंट कॉल देम इंडिपेंडेंट। इफ दे लाई इन ऑपोजिट डायरेक्शंस, then also I won't call it independent, because in that case one vector can be written in multiple of the other vector. If they lie in different direction like this, then they are independent vectors. One is lying in this direction, other is lying in this direction. So I cannot write this vector as multiple of this vector or vice versa, right? So set of independent vectors, मतलब यहाँ पे नहीं मिल गया। जैसे ये ऐसे, if suppose this is one vector, this is other vector. So if they are lying in this direction, one is lying in this direction, I'll call them, they are two independent vectors, right? They are two independent vectors. They may not be normal to each other, but if they are lying in different direction, then they can be said independent vectors. Means you are given say one vector like this. This is one ket vector. This is the other ket vector. Then these are independent vectors. Independent vectors. What Gram does is, Gram-Schmidt, two mathematician. So what Gram is doing is converting set of independent vectors to set of orthogonal vectors. ठीक है, ये इसको ऑर्थोगोनलाइज कर देगा. It will generate from set of two independent vector, it will convert it into set of two orthogonal vectors, right? And then what Smidt will do is, it will convert them into set of orthonormal vectors. है ना. अब देखिए कैसे होता है काम, कैसे हो रहा है ये देखिए आप, ठीक है. पहला तो हम लोग psi1 को ही psi1 को ऐसे ही रन देंगे. लेट्स पुट psi1 लाइक दिस, ठीक है. psi2 हमारा ये है ना, और हमें psi2 को psi1 के परपेंडिकुलर करना है. I have to generate, I have to orthogonalize them. ऑर्थोगोनलाइजेशन कहते हैं इसको, ग्राम-श्मिट ऑर्थोगोनलाइजेशन, ठीक है. ग्राम-श्मिट ऑर्थोगोनलाइजेशन. We are seeing how we can convert independent vectors into orthogonal vectors, ठीक है. तो क्या करेंगे आप एक काम करिए, आप psi2 का प्रोजेक्शन लो, राइट. psi2 का प्रोजेक्शन लो psi1 के along. So what will be projection of psi2 along psi1? The projection of psi2 along psi1 will be given by what? It will be given by projection operator this, And what is projection operator? पढ़ाए थे आपको, ये प्रोजेक्शन ऑपरेटर है. दिस इज प्रोजेक्शन ऑपरेटर फॉर साई वन वेक्टर. आप इसको किसी वेक्टर पे ऑपरेट कर देंगे, वो वेक्टर का प्रोजेक्शन साई के अलॉन्ग दे देगा ये. दिस इज प्रोजेक्शन ऑपरेटर. सो दिस इज गोइंग टू बी this is projection operator. So if I operate it on psi 2, I'll get this, right? अब अगर psi 2, we can see psi 2 as let's call this vector as zeta 1, right? And we can have a component of psi 2 which is perpendicular to psi 1, and I can call it zeta 1 mat bolo, it will be very confusing. Suppose we have psi 2 double dash. Why double dash? Because I'll psi 2 dash will be perpendicular to psi 1. And psi 2 can be seen as linear combination of its component along psi 1 and its component perpendicular to psi 1. ऐसे लिख सकते हैं ना. psi 2 can be seen as, I can split it psi 2 as psi 2 dash, which is the component of psi 2 perpendicular to psi 1 plus किसी वेक्टर के लिए ट्रू है. If I given two vectors, then I can take component of psi 2 along psi 1 and component of psi 2 perpendicular to psi 1, and I can see this vector as psi 2 dash plus psi 2 double dash, and psi 2 dash is perpendicular to psi 1. So I basically need psi 2 dash because I have to convert set of two independent vector to set of orthogonal vectors. तो एक तो आपका psi 1 हो गया, दूसरा psi 2 dash will be nothing but it's psi 2 minus, so this psi 2 dash will be perpendicular to psi 1, right? हमने क्या किया है, psi 2 में से जो पैरेलल कॉम्पोनेंट उसको बाहर निकाल दिया. psi 2 में जो psi 1 के पैरेलल जो कॉम्पोनेंट है उसको we have deducted it. So what remains is the component which is perpendicular to psi 1. समझ में आ रहा है आपको? हमने क्या किया, psi 2 का जो component psi 1 के along था, I have kicked it out. So what remains is the thing which is perpendicular to psi 1. So this is nothing but, I can write it as psi 2 minus, ये तो स्केलर हो गया, अपॉन, थोड़ा सा ऊपर करना था इसको, psi 2 dash is, psi 2 double dash is this. So what remains is, this is scalar, right? This. So this is your so this is perpendicular to psi 1. So we have converted, this is psi 2 dash which is perpendicular to psi 1. This is psi 2 dash which is perpendicular to psi 1. तो हमने क्या किया, we have given psi 1 and psi 2 and we have converted these vectors to a set of perpendicular vectors, orthogonal vectors. समझ में आ रहा है आपको? You can check that psi 2 dash is perpendicular to psi 1, and how do you check it? You just take dot product with psi 1. आप psi 1 के साथ dot product ले लो, आपका check हो जाएगा. if I take dot product of psi 1 with psi 2 dash, I should get 0. Only then I can say psi 2 dash is perpendicular to psi 1. So this will be what? This will be this minus and dot products are scalar. So this is 0. So that means psi 2 dash is indeed perpendicular to psi 1. Psi 2 dash is indeed perpendicular to psi 1. ठीक है, समझ में आ रहा है आपको ये चीज? So you see how we convert a set of two independent vectors into set of orthogonal vectors. Set of two independent vectors into set of orthogonal vectors. And now what Smidt will do is I can normalize them, and then these two vectors psi 1 and psi 2 dash, they can be normalized, and then I'll get set of two orthonormal vectors. Set of two orthonormal vectors which Smidt will do, right? देखिए I can convert them into set of two orthonormal vectors, say phi 1 and phi 2. So phi 1 is simply psi 1 upon norm of psi 1. If I divide the vector by its norm, it becomes normalized simply. If I divide vector by its norm, it becomes normalized. So this norm is nothing but square root of dot product with itself, right? Similarly, the other now orthonormal vector will be phi 2, which is nothing but psi 2 dash upon. So you see how we have converted set of two orthogonal vectors into set of two orthonormal vectors. Set of two orthogonal vectors into set of two orthonormal vectors. And this is what is Gram-Schmidt orthogonalization. यही Gram-Schmidt orthogonalization है. This is Gram-Schmidt orthogonalization, right? I can do it for three vectors also, and then I can generalize it. Suppose we are given psi 1, psi 2, and we are given one more vector, say psi 3. Psi 1, psi 2, psi 3 are psi 1, psi 2, psi 3. They are independent. How do you visualize three vectors to be independent? There are two vectors independent. Two vectors said to be independent if they are lying in different direction. Three vectors will be said to be independent if they are non-coplanar, like something like this. See, they lie in different direction and they are non-coplanar. I can't write one of the vector linear combination of the other. If I do something like this, say this, यहाँ they are lying in different direction, but now they are coplanar. Now they are coplanar, and in a plane you can't have more than two independent vectors. It's a two-dimensional plane, so I can write any of the vector linear combination of the other two. So in that case, the three vectors are not independent. If you want the three vectors to be independent, they must be non-coplanar. Means they should not lie in one plane. They should not lie in one plane. This is non-coplanar, right? So three vectors are said to be independent if they are non-coplanar, right? So we are given three independent vectors, psi 1, psi 2, and psi 3. So how to convert them into orthonormal? I take first orthogonal vector to be psi 1 itself. Then I have orthogonalized psi 2. Psi 2 को हमने orthogonalize कर दिया. How? We have taken out the component of psi 2 which is parallel to psi 1, right? Now how to orthogonalize psi 3? To orthogonalize psi 3, right now I have two vectors which are orthogonal, psi 1 and psi 2 dash. Now in order to orthogonalize psi 3, what I will do is I will take out the component of psi 3 which is parallel to psi 1 and psi 2. If I take out the component which is parallel to psi 1 and psi 2 from psi 3, then what remains is the component which is perpendicular to psi 1 and psi 2. Getting a point? I am given two vectors psi1 and psi2 dash. Now I want to orthogonalize psi3, right? I want to make psi3 perpendicular to psi1 and psi2. So what I have to do is I take out from psi3 what? The components of psi3 which is parallel to psi1 and which is parallel to psi2. So if I take out those components, what remains is the thing which is perpendicular to psi1 and psi2. So in order to take out from psi3 the component which is parallel to psi1, the component which is parallel to psi1 will be how, what? It will be I apply projection operator, right? So this is component which is parallel to psi1. Now I take out the component which is parallel to psi2. The component which is parallel to so this will be the vector which is perpendicular to both psi1 and psi2. This will be a vector which is perpendicular to both psi1 and psi2. What I have done is simply as same as what I did here. हमने projection operator corresponding to psi3 will be what? The projection operator corresponding to psi3 will be simply this. Sorry. So not psi3, psi2. The projection operator which is parallel projection operator for psi2 will be this is projection operator parallel to psi2. So if I want the component of psi3 along psi2, what I need to do is simply this. This will give you the component of psi3 parallel to psi2. So it's nothing but no, sorry. This same as what I wrote here. यही चीज लिखा ना यहाँ पे, ठीक है? क्लियर है? ओके, फाइन. इसी तरह से अगर आपको एक चौथा वेक्टर दे दे, if I given four independent vectors psi1, psi2, psi3, psi4, then I can normalize them, I can orthogonalize them. psi1, psi2, psi3 कैसा orthogonalize किया तो यही तक दिखाई दिया. अब psi4 को भी orthogonalize कर सकते हैं. I have to take out the component of psi4 which is along psi1, psi2, psi3. So if I take out those components, what remains is the component which is perpendicular to psi1, psi2, psi3. So this will be nothing but psi4 minus in the same way. You can check it also that they are perpendicular to each other. So this is component which is parallel to psi1. Now the component which is parallel to psi2 will be and the component which is parallel to psi3 will be like this. So this is I orthogonalize psi4. I orthogonalize psi4. And in the same way, if I am given infinitely many vectors, I will orthogonalize in the same way. And normalizing is very easy. You will divide by norm. Then the set of independent vector will convert to a set of orthonormal vectors. If I first thing, I will use Gram-Schmidt to orthogonalize them, and then I can divide each vector by its norm. Like I told you, phi 1 is simply psi 1, phi 2 is psi 2 upon is norm, phi 3 is psi 3 upon psi 3 dash, sorry, dash, in the same way, under root. Okay. So normalizing is very easy, and orthogonalizing, this is the way you orthogonalize them. This is the way you orthogonalize them. So this is all about Gram-Schmidt orthogonalization. You can, if you are given a set of independent vectors, number of those independent vectors can be infinite. So Gram-Schmidt tells you how do you convert set of independent vectors into set of orthogonal vectors, and this will be useful ahead. आगे जो पढ़ेंगे उसमें थोड़ा useful रहेगा. So this is all about Gram-Schmidt orthogonalization, right? So till then, thank you very much and have a good day.